Okay, Algebra 2 students, in this video we will be adding, subtracting, multiplying, dividing, and finding the composition of functions. After all of that, we're going to wrap up this lesson by finding the domain and range of graphed functions. So you can tell it's going to be a pretty intense long video. We have a lot to learn, and that's why I'm not giving you homework today. Please take really good notes. Alright, here we go. Your heading today is called Operations of Functions. Lesson 6.2, and be sure and include today's date. Copy this down, please. Operations of functions. Lesson 6.2, and be sure and include today's date. For the most part, this material is pretty simple, okay? Probably out of the 5 operations, 1, 2, 3, 4, 5. Out of the 5 operations listed above, finding the composition of functions is the hardest, and it's really not that difficult, okay? Finding the domain and range of a graph can be a little confusing, but we'll get through it. And I will show you how to do that so that you'll understand it. Let's start off by taking a look at these two functions. So in your notes, I would like you to copy down f of x equals 3x and g of x equals x minus 5. Please take a second and copy down these two functions. Okay, I'm going to move on. If I'm going too fast, just pause the video. First of all, I would like us to add two functions, f plus g of x, okay, equals, well, here we go. First of all, you have your f function, and that's 3x. I always use parentheses, guys, always. I think that's the safe, smart way to do it. So here's my f of x, right here. F of x equals 3x. So where f of x was, I put 3x. Next comes a plus sign. And then g of x, well, g of x equals this. So I'm going to pick that up and put it right here. Now, notice notice that these two are adding. They're not side by side, okay? If they were side by side, like this, if the 3x was right next to the parentheses like that, then the two parentheses would be multiplying. You would take the 3x and you would multiply it through times both terms. But it's not side beside it. There's a plus sign here, so even though you can't see it, there's a positive sign here. A positive times a positive is a positive 3x. And then you have a positive here. If you take a positive and multiply it through, none of the signs will change. So your x will still be positive, and your 5 will still be negative. And now we're ready to combine like terms. 3x plus 1x is 4x. Bring down your negative 5. And there's your answer. Look that over. Let that sink in. Watch it again if you need to. Adding two functions is not that difficult, okay? Let's take a look now at subtracting two functions. Okay, so we're going to subtract two functions now. F of x minus g of x. So f of x comes first, which is 3x. Then minus g of x. G of x is this, right here. So minus parentheses x negative 5. Now once again, students, if the 3x was right next to the parentheses, then yes, we would take the 3x and multiply it through. But it's not. So here's what we have. We have a positive sign here, even though you can't see it. So a positive times a positive gives you a positive. Here we have a here we have a negative sign being multiplied through. A negative times a positive gives you a negative. And a negative times a negative gives you a positive. Do you see how I did that? If there would have been a 2 here, then you'd have a negative 2 times x would be a negative 2x. And a negative 2 times a negative 5 would be a positive 10. Whatever's right next to the parentheses, you multiply that through, okay? So, take the negative and multiply it through. Negative times positive is negative. Negative times negative is positive. Now, combine your like terms. Here's an x term. Here's an x term. 3x minus x is 2x. Positive 5. 2x positive 5. So there you go. That is what you get when you subtract f minus g or f of we go. I have my f function first, so 3x times, and you're welcome to put the dot there, that's fine, and then times your g function, which is x minus 5. Personally, I would not put the dot there, but you're welcome to. I just know the two functions are multiplying, so they're side by side, okay? So there we go. So I have one function, my f function, times my other function, my g function, okay? And by the way, just so you know, let me stop and say something. You see all these notations here. Another way to write this is f plus g. That would mean the exact same thing. F minus g would mean the exact same thing. F, g like this, side by side, would mean this right here. So there are other notations that can be used, okay? So do understand that. If you want to make note of that, you can. You don't have to. Alright, now, so we're going to take 3x and multiply it times x minus 5. So you take the 3x and you multiply it through. 3x times x. 3x squared. 3x times negative 5. Negative 15x. And we're finished. Now, some students make the mistake of combining these two terms together. A positive 3 and a negative 15 would be a negative 12x. Or 12x squared, whatever. That's not correct, guys. Remember, you can only add or subtract or combine, whatever word you want to use. Like terms. This is an x squared term. This is an x term. They're unlike terms, so you cannot combine them. Now, you can multiply unlike terms. Look up here. This is an x term. This is a constant term, right? And we multiply them together. You can definitely multiply unlike terms. You cannot combine or add or subtract unlike terms. Okay? So that's it. We're finished. Moving on. Okay? Now, we're going to take two functions and divide them. Now, let's really be careful here, okay? I have my f function. That's 3x. Divided by my g function, x minus 5. Now, I need to talk to you about this, because if you don't listen to me, a lot of you are going to make mistakes on these problems. First of all, we're finished. There's nothing we can do. That's your answer. Now, here's what a lot of you probably want to do. You probably want to cross off your x's and write 3 over negative 5. You cannot do that. Please listen to me. This is one term up here. Now if I had a plus sign here, or a minus sign here, then I would have two terms. I've told you guys before, positives and negatives are what split up an expression into terms, okay? So this minus sign here, this negative sign, splits this expression up into two terms. Here's my first term. Here's my second term. There is no positive or negative. This is one term here. 3x is one term. So, anytime you have different terms like this, you cannot cross off an x unless you're going to do it to every term. So, if there was an x here, then yes, you could take an x away from every term, and you would have 3 over negative 5. That's totally fine. But we don't have an x with the 5. Here's something else some of you are going to want to do. What if this 5 would have been a 6? Some of you are going to cross off the 3 and put a 1, and cross off the 6 and put a 2, and put 1x over x minus 2. That's incorrect. You cannot do that, okay? You cannot do it, because if you're going to reduce, you must do it to every term. Now, if this was a 15, and this is a 6 right here, then every term can be reduced by 3. This would become a 1. This would become a 2. This would become a 5. 3 divided evenly into all the terms, so you would have 1x over 2x minus 5. And that would be okay. But if you're going to reduce the fraction, you must reduce every term. Every single term, okay? I mean, if there was a 3 here, you could not cross off those two numbers, because 5 is not divisible by 3. Now, if that was a 6, then you could cross off the 3, cross off the 3, cross off the 6, make it a 2, and reduce it. expression, and that's what this is called. We'll get into that later, but it's called a rational expression. If you're going to simplify a rational expression, you must reduce every term. You must reduce every term, okay? Or factor, and we get to that later, not now, okay? So if you're going to reduce a rational expression, you must reduce every term, okay? So that's your answer. We're done. Not too difficult, okay? So, like I mentioned to you, adding, subtracting, multiplying, and dividing is really pretty simple, okay? So that's not too bad. But now, let's see how you guys do with composition of functions, okay? It's going to get a little more difficult now. So, get your thinking caps on, be ready to pay attention, take some good notes, and here we go. Let's use these two functions. So take a second and copy those two functions down. We have a g function here. This is my g function, and this is my h function here. Alright, I'm going to move on. Feel free to pause the video if you need to. Now, this is what composition looks like. We read it like this. F, you might want to make note of this. F of g of x. F of g of x. That's how you read this, okay? Another symbol used for composition is this. Now remember, there are more ways to symbolize different things. So that means this here, this expression here, and this expression here both mean f of g of x. And it means you're taking the composition of, and you know what? I should not have used, okay, my fault, I messed up here. In your notes, make this f, please, and make this g. Because I've got more pages coming up, and it would be better if I just make this function here f, and this function g, okay? Alright, sorry about that, but anyways, and what this means is we're taking the composition of f and g, okay? So this little open circle here, this expression here means the exact same thing as this expression here. Now, what does it mean? We'll take some really good notes. I'm going to walk you through this step by step by step, but you've got to listen to me and take good notes, okay? Alright, what is the first letter you see here? F. So you write your f function. However, when you write it like this, everywhere there's an x, you're going to put a big parentheses. Now, isn't that easy? Everyone can do that. That's not hard. What's the first letter outside the parentheses? F. That tells you to go to the f function and write the function, and where there's an x, put a big parentheses. Now, what's the next letter you see? G. So you're going to pick up your g function and put it in the parentheses. So basically, remember the other day we learned f of 5 means to put 5 in for x. Remember that? For this function right here. If I say evaluate this function at f of 5, everywhere there's an x, you would put what? 5. Remember that? We learned that yesterday. Well, this is the same thing. Instead of a 5 being here, we have g of x. So what that means is to pick up g of x and put it into f. That's what we're doing. We picked up g of x and we substituted it into x. Everywhere there's an x. That's all we did. So now we simplify and we're done. This 2 is right next to the parentheses. Let's multiply it through. 2 times x squared. 2 times negative 3. 2 times positive 5. And then bring down your positive 3. Now combine your like terms and you're finished. There's only one x squared term, so bring it down. There's only one x term, so bring it down. Here's 2 constant terms. Combine those and, wow, where'd I get 7 from? That's interesting. There we go. Okay. So there's your answer. That's f of g of x. F of g of x equals this right here. And let's practice, 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 guys. That's what you need, okay? You need to practice, so here we go. G of f of x. Okay, no problem. What letter comes first? G. So pick up your, and by the way, remember this is f in your notes, this is g in your notes. Pick up your g function, and everywhere there's an x, we're going to put a big parentheses, okay? So it's an x here, put a big parentheses, don't forget your squared, then negative 3, then an x, so put a big parentheses, then bring down your positive 5. Now what comes next? What's the next letter? F. So we're going to pick up f and put it in the parentheses. This is going to be a lot of work. Sorry, but it is. We have 2x plus 3 to the second power. You see that? So what that means is 2x plus 3 times 2x plus 3. Okay? What we're doing now is simplifying. We made our substitutions. We wrote the g function. Then we picked up our f function and we substituted it into the g function. Now we're simplifying. Okay, I have a binomial, a two-termer, times a binomial. 2x times 2x, 4x squared, 2x times 3. So I took my 2x, I multiplied it through. Now take your 3 and multiply it through. 3 times 2. 3 times 3. Now we have a negative 3 next to a parentheses. So take your negative 3 and multiply it through. Negative 3 times positive 2. Negative 3 times positive 3. There we go. Then bring down your positive 5. Now, let's look for like terms. I only see one x squared term. So I'm done with that. Here's an x term, an x term, and an x term. 6 plus 6 is 12, minus 6 is 6. So we're done with our x terms. There's 3 constant terms, positive 9, negative 9, positive 5. Now, positive 9 and negative 9 would cancel out, leaving you with positive 5. So there we go. You just found g of f of x. G of f of x. Okay? Alright, let's practice 2 more of these. How about f of x? F of x. Well, let's see. Actually, we'll do one more and that'll be sufficient, I believe. F of x. Okay? So, here we go. What's the first letter on the outside? F. So you take your f function, and everywhere there's an x, we're going to put a parentheses. What's my next letter? F. So you're going to pick up f and put it in the parentheses. And here we go. Let's simplify now. This 2 is right next to the parentheses. Let's multiply it through. 2 times 2x. And 2 times positive 3. And then bring down your positive 3. And now combine your like terms. 4x, positive 9. 4x, positive 9. So f of x, or f of x equals 4x plus 9. That's it, guys. That's all you have to do on these. So you need to practice them and understand that they're not super difficult. They're not super hard, but you got to understand how to do these, okay? Alright, let's continue on. Okay, we're learning a lot in this video, okay? Let's wrap this up now by looking at graphs and finding their domains and ranges. Now, remember when I asked you to find the domain, that's dealing with what? X. Remember your interchangeable terms. Domain, X, independent variable. What was the other one? Domain, X, independent variable, and input. Range is Y, or dependent variable, or your output. This is your input, output, okay? So when I ask you to find the domains and range, we're dealing with x and y values, okay? Now watch, this can be really confusing if you're not careful. So please be careful. Watch carefully. First of all, I'm going to deal with my x values. So the wisest thing to do, in my opinion, is just to cross off the y-axis so that you don't get confused by it. Just ignore the y-axis. The only thing we're going to look at is the left and the right behavior of the graph. Now, Mr. Earhart, why the left and right behavior? Because we're dealing with what? Domain. Domain deals with what? X. And doesn't the x-axis deal with the left and right of the graph? Sure it does. The y values deal with the up and down of the graph, the vertical movement. X deals with the horizontal movement. So, I have a question for you. What is happening to the x's in relationship to this graph? Well, as the graph is going up, it's going to continue to go to the left. A parabola never goes like this. A parabola never gets to the point where it finally starts going straight up and down. That does not happen, okay? So even though it might be really gradual, this parabola will continue to go up. And as that continues to go up, it'll continue to go left also. As this side of the parabola continues to go up, it will continue to go right. So there's no boundary to the left or to the right. In other words, this graph, if you kept graphing it, would go up, 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 and further to the left and further to the right. So the domain for this graph would simply be all real numbers. That's it. That's easy, guys. Think about it. There's no limit to your x values. This graph continues up and to the left and up and to the right. So your domain is all real numbers. However, we're going to do some more of these. Just sit tight and watch, okay? However, look at the range now. The range is a little different. Now I'm going to deal with the range, which is my y values. So I'm going to cross this off so I'm not confused by that, okay? Alright, now. Now I'm dealing with my range, so I'm dealing with the vertical movement, the up and the down. Now, obviously, the graph's going to continue up, up, and up, right? That's obvious. There's arrows on the graph. It'll continue on and on. But does it continue going down, down, down? Of course not. It stops right here. So where is that at on the y-axis? Well, from here to here is -2. Each tick mark on this graph is 2. So from here to here is -2. So from here to here's 1, and we're about right here. I would say that's about 0.2 probably. So the range is going to be all real numbers greater than -0.2. How do you know that, Mr. Earhart? Well, I'm going to show you why. We're estimating that this graph goes as low as -0.2. We're just estimating, okay? -0.2. Now, does the rest of the graph go below that value or above it? Obviously above it. The graph's up here, above that. So the range is all real numbers greater than -0.2. Now if the parabola would have looked like this, then you would have put all real numbers less than -0.2 because the graph was below -0.2. Okay, but that's not the case here. The graph is above it. So there's your domain and range. Now we're going to do more of these. 3 more, okay? So just try to stay with me and let's see how you do on these, okay? Alright, let's get another problem up here real quick. y-axis. So I'm going to cross off the y-axis. I want nothing to do with that. I'm looking at the left and the right behavior. Now, is it going to continue on and on to the right? Yes, it is. The graph goes on and on forever to the right. So there's no boundary to the right. Is there a boundary to the left? Well, yes. It stops right here. Where is that equal to on the x-axis? -1. Do you see why I crossed off the y-axis? I don't want you looking at those numbers. Sometimes students get confused with which numbers to use on which axis. We're dealing with domain, which deals with x, so cross off your y's. Okay? So, this graph does not continue to the left. It does not. It stops right here at where on the x-axis? -1. So I have a question for you. Is the graph going to the right of -1 or to the left? It's going to the right. So you would say all real numbers greater than -1, because the graph starts here at -1 and goes to the right. Oh, my fault. And it also equals, should be equals. -1, there we go. All real numbers greater than or equal to -1. It's equal to because it's right there as part of the graph. There we go. Same thing on the last problem too, I should have mentioned, and I apologize. Go back and look at your notes, guys. That should have been the range, should have been all real numbers greater than or equal to -0.2. Let me say that again. The last graph we looked at, it's too late to bring it up. I already deleted it. But for the range, it should have said all real numbers greater than or equal to -0.2. Okay? So anyways, there is my domain. Now let's take a look at the range. I want to encourage you to cross off the x-axis. Cross it off. We're not going to look at those numbers. Cross them off, okay? We're dealing with range now, which is your y values, okay? So, we're dealing now with the vertical behavior up and down. Well, obviously, guys, as this graph continues going to the right, it'll always continue getting higher and higher. So there's no boundary going up. However, there is a boundary going down. It stops right here. It's not going to go any further down. Where it stops at right here, where is that equal with on the y-axis? Let me get rid of this so you can see it a little bit. Where this stops at right here, where is that equal to on the y-axis? 0 right there, right? So that means you're going to stay above 0 on the y-axis. Now you can see why I want you to cross off the x-axis, because some students would not know whether to take numbers from the x-axis or take numbers from the y-axis. We're dealing with range, so we're dealing with y's. So do not look at these values on the x-axis. Look at the values on the y-axis. Here's where it stops. Where is that equal to on the y-axis? 0. So the graph goes above 0. So you would say all real numbers greater than or equal to 0. That would be your range. Okay? And I'm not sure what I clicked there. I guess I clicked Microsoft Word. There we go. Alright, let's try another one. And did not mean to do that either, so here we go. Alright, let's try another one. This one you can probably get on your own. It's another parabola, so feel free to pause the video and try it on your own if you want to, or you can watch me do it, okay? That's up to you. Alright, here we go. go. Let's start off with the domain. The domain deals with x, so I'm going to cross off my y-axis. I want nothing to do with the y-axis numbers. Okay, let's talk about the right and left-hand behavior. As for the left-hand behavior, the graph's going to always continue moving left as it goes downward. Even though it'll be very gradual, it will always continue to go to the left. Also, as this graph goes downward, even though it's going to be really gradual, it will continue to go to the right. So there's no boundaries on the left or the right side. So my domain would be all real numbers. Now let's talk about the range. Range deals with y. So I'm going to cross off my x-axis numbers. Don't even look at those guys, students, okay? Now range deals with the up and down behavior or the vertical behavior of the graph. Now obviously there's no boundary going downward. It's going to continue going down, down and down, and down and down and down, okay? But there is a boundary going up, and it's right here. Now where is that at on the y-axis? Remember, we're dealing with range, which deals with the y values. So forget the x values, cross those off. Now, it looks like on the y-axis, from here to here is 2, so it looks like it's kind of in the middle. So we're going to say it's kind of at 1 there, okay? Now, at 1, does the graph go below or above it? Well, obviously it goes below 1, so you would say all real numbers less than or equal to 1, okay? Because you're staying below the number 1, so all real numbers less than 1. Alright, let's try one more. This last one, I'm going to tell you now, this last one's really difficult. I will not give you any of these types on your test or quizzes at all, okay? This type right here, I do give you one on your homework, but of course watch the help video and it will help you a little bit, okay? Alright, here we go. Now let me start off by saying I'm not really sure why they gave this to you, because we've not really covered yet, the book hasn't covered yet, asymptotes when it comes to graphing. Asymptotes. But that's okay, we'll talk about it now. Remember, relax, I'm not going to give you any of these on a test or a quiz, but what you don't understand is there's an imaginary boundary here that neither one of these graphs are going to cross. And there's another imaginary boundary about right here that those two graphs will not cross, okay? And so, now that I've told you that, I'm going to walk you through it. It's a really tough problem. Some of you might not understand it, which is okay. Again, none of these will be on your test or quizzes. I just wanted you to really take a look at this and just try to understand it, okay? And maybe some of you will. Okay, let's start off with the domain. Now we're dealing with the x values, so I don't want to even look at these y values. They mean nothing to me, okay? We're talking about the left and right behavior of the graph. Now, it looks like to me the graph is going to continue to go to the left until it hits. It looks like we're in increments of 3 on this, aren't we? Yeah. So this boundary right here is at -3. This boundary here. So it looks like to me the graph's going to continue going to the left-right arrow. And it's going to continue going to the right also until it hits -3. Now this graph does the same thing. It continues going to the right. But it had to start at -3. That's where we're at here on the x-axis, -3. So this domain would be all real numbers except -3. Except -3. That's an equal sign with a slash through it. In other words, all real numbers except -3. Okay? Now I knew that because, look, I knew that because the graph was continuing to the left forever and ever, continuing to the right forever and ever. There was just one place that the graph could not go, and that's at -3 on the x-axis. Now let's talk about the y, the range, okay? Here's my imaginary boundary here. So we're going to cross off all the y values. We don't care about those, okay? We're talking about the vertical movement, the up and down movement, okay? Well, it looks like to me it's going to continue going up and up and up and up and up and up forever. And it looks like it's going to continue going down and down and down and down and down forever. So there's only one place where the graph does not exist. Going up and down, that's on this boundary right here. This boundary right here hinders the graph from crossing that boundary, going below it or above it or above it or below it or whatever. So here's the deal. I know the graph continues upward forever and ever, and downward forever and ever. However, there's one place here, we're going to call it 3. No, I'm sorry, from here to here's 3. So we're going to call it half of that, so we'll call it 1.5. Just an estimation is fine. So, the graph is going to continue to go up and down everywhere, except where on the y-axis, 1.5. So I'm going to say all real numbers except 1.5. And there we go. Alright. Now again, relax. This was the hardest one. I'm not going to give you any of these types here on a test or a quiz. There are 1 or 2 of these on your homework that you're going to do later. So just use the help video, do the best that you can, and we'll go from there. Okay? I hope this video's been a help to you. If you have any questions, don't hesitate to call or email.